Good morning, everyone. My name is Jeremiah Dooley, and I am one of the principal architects in the NetApp SolidFire Office of the CTO, and I'm happy you joined us today. I'm happy to have a little bit of time to walk through what SolidFire is doing, what we've done as part of the acquisition by NetApp, and some of the technology that we're using to solve challenges for customers who are looking to adopt storage into public and private cloud environments within their data centers. So as we go through here, a couple of housekeeping items. Please feel free to ask any questions that you want to in the chat. We've got a couple people who are looking at that, and if there are any questions that need to be brought up during the discussion, they will certainly do so. Otherwise, we will go through together and look at the questions that are in chat at the end. And if you have any questions, just go ahead and throw them in there. So with that, we will go ahead and get started. When we look back at the SolidFire product, it's important to recognize that we were trying to solve a reasonably different problem than most of the storage vendors in the space. Most storage vendors start in the mid-market. They start with small customers. They start with small deals. They start with relatively small amounts of I/O. They start with very small scale, and they use that as a platform to be able to figure out how the product works and what the challenges with the product are, and make any mistakes that they need to at a real small scale with real small customers before they declare the product to be enterprise ready and then move up the stack. SolidFire did things a little bit differently. We started with the largest and most demanding of customers, large-scale web environments, large-scale service providers. And what we saw from them was that everybody was they were calling it different things, right? They had lots of different names, but what everybody was looking for was the ability to design, deliver, and support a next-generation data center. And when we looked at that, we found that there were four core things that they were looking for. They needed that storage to be agile. They needed the storage to be scalable. They needed it to be as automated as it possibly could be, and they needed it to be very predictable. There needed to be no differences in what the storage was able to deliver when it was new or when it was old or when it was empty or when it was full or when it was being worked on or when it was at 100% operating capacity. That predictability was really important. So regardless of what they called it, all of the customers that we originally targeted with the product had this idea of being able to deliver more than what their traditional storage could be. And the reason that this is important is because those traditional storage environments that they were using, those traditional storage architectures that they were using, became part of the problem over time. As everything in the data center got better, as we got better at virtualizing compute and memory, as we got better at building and scaling the network side of things, as we got better at security, as we got better at remote access, as we got better at all of these things, the storage largely remained the same. So the storage architectures that we saw in the last 2 or 3 years that are just coming to market looked largely the same as the storage architectures that were coming out 10, 15, 20 years ago. And there were two things that really accelerated that market shift. The first was the move from disk to flash. What we found was that those traditional architectures can be very challenged by the amount of I/O and by the amount of scale that is coming in very short order with the SSD manufacturers. And the second was that the idea of selling storage to storage people is largely going away. We see customers organizing themselves much more horizontally around business practices or around business outcomes, and that move from siloed to shared infrastructure has really driven the consumption model of customers who are looking to buy storage today. And the consumption models are an important point. Customers have lots of different ways, not just lots of different vendors to buy infrastructure from, but lots of different ways to consume that infrastructure. And so when we talked to customers and found out, what's important for you to choose your infrastructure, what we found was there's this continuum of ways that they're looking to buy things, right? So as a service means I never want to buy any capital or own any data center. Software and commodity hardware being the most the most specific, the most bespoke model of consuming that infrastructure where you buy whatever commodity hardware you want and you deliver the software that makes sense on top of it, and then a whole range of things in the middle. And when we looked at this and we started talking to customers, we saw that there was a very clear slant on the side size of the customers that were looking at these consumption models, right? The hyperscale and service provider customers more to the right, the SMBs and startups predominantly and heavily tilted to the left, the large enterprises picking and choosing from all of the environments to find the best way to deliver the resources that they needed to the applications. And we also found that these were very aligned to business values. So for customers who had a preconceived notion of how much vendor lock-in they were interested in, or how difficult or costly the implementation was going to be, or whether they were going to live at small scale or at large scale, we were able to start helping them figure out where in this consumption model they wanted to be. And why that's unique to SolidFire is because the product that we built, this Element OS operating system that we're going to talk about, and the 5 different pillars of feature sets that live underneath it, we have the ability to deliver them into any of those consumption model spaces. So for customers who want as a service, we've got hundreds of thousands of customers who are being provided SolidFire storage on a monthly or contract basis out of a data center that they may not even know is using SolidFire because they're using a product or they're using a service offering that is backed by it. And on the other side, with Element X, having the ability to deliver software and commodity hardware, our tried and true best-of-breed appliance model, or going with the converged infrastructure route and leveraging the impact that FlexPod has in both the partner communities and with customers. Our job is to take one product, Element OS, and make it available in as many of these different ways as we can without compromising the product or without changing how it's delivered or how it's consumed. Since SolidFire got acquired by NetApp, which happened in February of this year, it's been very fun to be part of a portfolio of Flash products that we can use to position both Flash and the NetApp value proposition into lots of different use cases. Generally speaking, with 3 different Flash products, we've got 3 products that are targeted at very different parts of the market. The EF product is very much targeted at single workload application acceleration. It's targeted at being able to put Flash raw, fast, no data services to get in the way, Flash as close to an application as possible to improve the performance of a database, to improve the performance of a point application. On the other end, SolidFire is the scale-out cloud version of Flash, designed specifically for virtualized infrastructures, designed to provide granular performance controls, guaranteed QoS, really drive consolidation. And then in the middle is the Swiss Army knife of all Flash storage arrays. And the AFF, very much aligned to traditional infrastructures, great at supporting any type of protocol, any type of file application, any type of platform integration that needs to be done, multi-protocol, all of these things that the FAS array has been known for forever and has really started to come into its own as part of the all-Flash version of it. Being able to sit in the middle and being able to take small workloads, being able to take large workloads, but then knowing if we have a single application to accelerate, there's a product, or if we've got a bunch of different applications we need to consolidate or that we need to support at scale, SolidFire is the answer there. So this all-Flash portfolio has been a very powerful tool for us to go out and talk to customers as they work their way through that transition from disk to Flash within the data center. And this is important because the SolidFire value proposition isn't necessarily isolated in one segment of the storage that's in the data center. Traditionally, we hear things from customers like, I really don't need Flash for these workloads, or Flash is really expensive. We want to be able to spend it as wisely as we can on the applications that need it. And there was certainly a time early on where the PCIe version 1 Flash and even the version 2 all-Flash arrays were very expensive, were not very scalable. Even as they started to introduce data efficiencies to help with the finances, what we had were things that were very siloed into that extreme performance pool, very siloed into being able to accelerate a single workload, the EF and storage array, the NetApp EF storage would be able to go into here. What SolidFire wanted to do was to be able to take all of the rest of that storage within the data center and consolidate it into a single array, right? Everything up to that extreme performance and then everything down to the line where general purpose data center storage runs into the cheap and deep object and file storage, right? The things that we use for archiving, for video streaming, for image repositories, for backups. Now, part of being in the NetApp family is that we certainly have technologies that can be brought to bear here, right? The AFF or the disk FAS, the hybrid FAS, makes a great play here on the left side of the graph, as do the storage-grade and AltaVault products. But that line to the left is really one of economics. And as the capacity of flash continues to increase, as the price per gig of the flash continues to decrease, as the storage arrays get better at harnessing that capacity, that line continues to move to the left. And the type of use cases that flash is appropriate for continue to increase. And that backup archive video streaming line, where we would traditionally see that cheap and deep storage, continues to move to the left of that. Now that's important because there's an awful lot of storage over to the left, right? It's not necessarily a large number of applications. It's not necessarily large performance, but it's a gargantuan amount of capacity. And having the right tool to be able to play in the right spot on the graph is certainly important. So let's look at the SolidFire storage array itself. The first thing to note is that we clearly are not a traditional storage architecture where you have two controllers and those two controllers are attached to a series of disk shelves with a loop architecture of some type or some type of interconnect, be it fiber channel or serial attached SCSI or InfiniBand or any other high-speed, low-latency backend. SolidFire is what we call a node-based, shared nothing, scale-out storage architecture, where each node in the cluster runs its own copy of the Element OS operating system, has its own CPU and RAM to be able to run data services, and run the operating system itself, and then each node owns its own set of disks. In the SolidFire SF nodes, each node owns 10 SSDs of varying sizes, and we'll take a look at the individual nodes and node type designs here in just a second. What's important to note is that while this is different, and every customer that we talk to, particularly those that are coming from a traditional dual controller environment, this is very different. It's been proven in some of the most demanding data centers on the planet, right? Not just large enterprises where availability and performance and uptime are critical, but service providers and financial institutions where availability literally equals revenue. And the ability to stay up, the ability to be able to do maintenance on them, the ability to be able to recover from component failure is absolutely critical. And so as we go through and talk about some of these features, recognize that while the architecture may be new and to you, and while the architecture may be different than what you're used to, it's very much something that we've tested under fire for the last 5 or 6 years with some of these gigantic companies and with some of these huge service providers. So the level of comfort we want customers to have in the architecture and in what we're doing with it is very high. And we've seen this not just from our customer base, which is the most important thing to us, but also from the industry. When Gartner releases its Magic Quadrant, it releases a critical capability study with it. Whereas Magic Quadrant is very much influenced by the size of the company and the size of the sales force and the amount of revenue that's being driven, and typically sees the startup players down in the bottom right with complete vision, but very much challenging, being visionaries rather than being leaders. The critical capabilities only looks at what the array is capable of doing. And these are the 5 different tests, critical capability tests that they provide us. And here's the rating that SolidFire got in each of those. So despite being a startup, our position as the most complete of the visionaries translated into the highest rated all-flash array for both 2014 and 2015. And so that combination of customer success plus the recognition that we are leading as a visionary inside the Magic Quadrant, but then particularly that the critical capabilities are something that we crush pretty routinely and show that the array, regardless of the size of the company, and certainly that's changed now as part of the acquisition to NetApp, but regardless of the size of the company, the quality of the array is top-notch. So let's talk about the SolidFire software. Element OS is the software that we build, and really it's the intellectual property that we protect, right? That's our product. That's the secret sauce of the SolidFire storage product. And we broke the feature sets of that storage product down into these 5 categories. And our job was not to be the best storage product for everybody everywhere. It was not to satisfy everyone all the time. Our job was to be the best that we possibly could be at at these 5 different things. And so as we go through here, we're going to talk about each of these 5 things and take a look a little bit at the technology and some of the stuff that we've got going in there. And as we finish each of these sections, there's a wrap-up slide that kind of shows the value of it. And at that point, if any of the other moderators on the call see a question that it would be great to jump in and answer, we'll do that at the end of each of these sections. Otherwise, we'll push that off to the end. So let's start with scale-out agility. Scale-out is very much a function of the node-based shared nothing architecture. There were a couple things that we wanted to drive with this. The first was that it's important to have linear and nonlinear scale, to be able to mix different types of nodes and different performance to capacity ratios in order to be able to deliver the storage pool that is relevant to the workloads or relevant to the consumption model that a customer needs was really important. We needed to be able to expand. So as we need more IOPS and more capacity, being able to add additional nodes in and scale that out in whatever method we want to was important. But really important to us was the ability also to contract. Adding more storage into a pool is great, but sometimes what we need is to take stranded storage and move it somewhere that it's needed, whether that's a second data center, whether that's a second cluster that's being dedicated to a specific business unit or tenant. Whatever that reason is, it's very important from a SolidFire standpoint that we never have storage that's sitting in a cluster that's stranded that can't be used. That's a huge hit to the TCO and ROI of the storage arrays, and it's something that a traditional environment where you've got shelves of disk attached to a pair of controllers struggles a lot, being able to take that capacity and performance and move it elsewhere and make it usable. So it was really important to us that we scale out and scale back. When we do this, we get a couple benefits out of this. The first is future-proofing the investment. We guarantee that every new version of software that comes out will run on every version of hardware that we've delivered. So there's never a problem where a new version of the software comes out and customers know that they have to walk away from or lose the investment that they've made in nodes in order to be able to take advantage of it. The second was one of the huge pain points that we talk to customers about is storage migrations and forklift upgrades, right? The 3-year hamster wheel of buying storage and letting it depreciate for 3 years and then knowing that I'm going to have to migrate all of that storage to a new controller in order to get new hardware and new software, and knowing that, for some period of time I'm going to have a few storage arrays on the floor and I'm going to have some process by which I move workloads and don't impact the customers who are using them. We wanted to be able to take all of that off of there completely. Being able to do rolling upgrades, being able to do upgrades and feature set upgrades and hardware upgrades and add new nodes and all of these things while the cluster is live and running was really important. And then finally, flash doesn't wait 3 years. When we look at the size of the flash disks and what they've done in the last 3 years, and if you bought a storage array and have had it sitting on the floor for the last 3 years, then you're missing out on the opportunity to get better price per gig. You're missing out on better density. You're missing out on all of the different things that have come about in that ecosystem over the last 3 years. And so what SolidFire really likes to be able to enable for customers is buy storage when you need storage, not when the timeline of the storage array that you bought last time dictates. And being able to add in a node at a time and take advantage of whatever new technology is out on the market is something that SolidFire customers have been really happy with. So when we look at this in practice, what we have here is a 4-node cluster of 2405s. And as we start to add workloads, we've got some SQL Server, we've got some OpenStack environments, we've got some VMware environments. We continue to use performance and capacity, and we load balance that and distribute that across all of the nodes in the cluster. At some point, we realize that we want to add more capacity in here. When we look at the SolidFire nodes, we see that there is a more dense node that includes more capacity for the same amount of performance. And so as this cluster fills up, then we start adding in new nodes. And in this case, we had 4805 nodes, so they're twice as large from a capacity standpoint as the nodes that were in the cluster. And then after we add those in, we go ahead and load balance that performance and capacity again across all of the nodes, regardless of node size. So what we've done is we've added new nodes. We've added probably better price per gig nodes into an existing cluster. All the load balancing happens on the background. All the operational staff needs to concern themselves with is that they have more resources to be able to allocate out. So as they start moving new workloads in, whether it's MongoDB or anything else, we continue to grow that. We continue to load balance that across. At some point, what we realize is the efficiency, cost efficiency, or amount that we're paying for support on the new nodes is much preferable to the amount that we were paying on the old nodes. So we can designate nodes to be removed. And when those nodes get removed, it takes the capacity and performance of those nodes, redistributes it across everything that's left in the cluster. All of this happens online. No data migration. No worrying about how am I going to transition everything over to a new storage array in order to get better economics or better ROI. I just had to buy the nodes that made sense and let the storage array do what it's supposed to do. When we look at the scale-out side, simplifying the capacity planning, all we need to look at is capacity and performance, seamless generational upgrades, no more forklifts, instant data resource availability, being able to eliminate hotspots, being able to eliminate manual load balancing or figuring out tiering policies or understanding what that tiering is going to do to the CPU of the controllers. These are the things that we really tried to solve with the scale-out portion of Element OS. Okay. We'll go ahead and look at the next section. Kind of goes hand in hand with the architecture of the self-healing, and this is the high availability. SolidFire Helix is what we use to be able to do data protection, RAID-less data protection across a cluster no matter how many nodes are in it. What we're driving for here is no single points of failure, and most importantly is we're very much trying to minimize the time at risk. Philosophically, there are two ways that you can do data protection in a storage array. One is you can allow the customer to overbuy and over-provision and use spares and use RAID stripes with multiple different parity drives in order to be able to protect against multiple failures and the significant amount of time that it takes to rebuild or repair after one of those RAID-based failures. And when we look at traditional storage arrays, that's the way most companies, most customers have gone, right? I've got triple parity, I've got RAID 6, I've got hot spares, and I know that if one of those drives fails, particularly one of those larger drives, I'm going to have a significant amount of time that my storage array is in some level of degradation in order to be able to rebuild a drive from parity, replace a drive, those sorts of things. What SolidFire chose to do is very much minimize the amount of time that an array is at risk. And we do this by making sure that no matter what happens, if we have a drive fail, that we can reprotect all of the data that was on that drive in about 8 minutes. And that happens fully automated. There's no acknowledging the fault. There's no going down and putting a new disk in. As soon as the cluster recognizes that there's a disk fault, it kicks the disk out of the cluster. It reprotects the data that it knew to be on that disk. And within 8 minutes, the storage array is back at 100% redundancy, at 100% performance. There's no lingering impact and no worrying about, I've got 12 hours to do this rebuild or 18 hours or 24 hours to do this rebuild on this drive. What's going to happen in the meantime and what sort of performance impact am I going to have? Our job is to get that replaced and repaired in as automated a fashion as possible as quickly as we can. And that happens the same for the node rebuilds, right? So if an entire node fails, we do the exact same thing. We recognize that it failed, we kick it out of the cluster, we reprotect the data that was on there. In a worst case environment, smallest number of nodes, largest nodes we have at full capacity, takes us about 48 minutes to be able to fully reprotect all of the data that was on that node and get everything back up and running the way it was supposed to. For both of those, the drive failure and the node failure, the time to repair those gets smaller as the cluster gets bigger. We have the ability to do more simultaneous reads and writes in order to be able to reprotect the data that was on the component that failed. And so as the cluster gets bigger, those rebuild times get smaller, which is certainly a benefit of the SolidFire architecture. So in this case, just to visually see it, when we lose a node, all of the data that was on that node gets redistributed. We rebalance the performance and capacity across the cluster. If we lose another node, the same thing happens again. We know what data was on there. Customers can lose as many nodes as they have capacity to be able to replace. So if a customer decides that they want to go n+1 or n+2 or n+5 on the nodes that they have in the cluster to be able to handle these failures and being able to reprotect that data elsewhere in the cluster, customers can decide how much of that protection that they want. It's not necessarily built into the architecture. Customers can add as many nodes as they want to. Benefits here, we really want to reduce the risk of incorporating Flash. Flash has a much better reliability, and being able to leverage that in the architecture is important to us. Hands-free problem resolution. We don't want someone to have to go to the data center at 2 in the morning to fix a bad drive. No single point of failure, no loss of data. We wanted that to be as automated as it possibly could be, and the Helix data protection system is our answer to that. Okay. Next, we'll move into quality of service. So what we did was we created a great big pool, right? A great big, highly available pool of performance and capacity. In a traditional environment, that doesn't get us a whole lot because now we just have to provision workloads into it. What SolidFire did was take the pool and give it the ability to be logically allocated. So for every storage volume that gets provisioned on a SolidFire array, we have to have capacity, just like every other storage array. But what we have that is special is that every volume gets a minimum, a maximum, and a burst amount of IOPS that are specifically allocated to it. This gives us the ability to protect individual workloads from other workloads that are on the array. It also gives us the ability to allocate, to provision performance and capacity separately. If I need a huge volume with a little bit of I/O, something that I traditionally would have put on a hybrid or spinning disk array, I can provision that inside a SolidFire array and not burn I/O that could be better used elsewhere. And conversely, if I have a very small volume that needs a lot of performance, something that would typically be allocated out to an all-flash array, I can handle that and free up that capacity to be able to provision elsewhere. So the idea of this isn't a workload that we necessarily need Flash for, can be done away with in favor of consolidating more workloads onto a single platform and driving better ROI and TCO and driving better operational costs. And if we look at an example of this, what we've got here on the left is a database that only has a minimum IOPS of 100. And on the right, we've got a VDI bootstorm. And we've got 200 volumes that are 200 VDI instances over 2 different volumes that rebooted, and we can see the impact that it has. We can see the amount of bandwidth on the storage array and the I/O on the storage array go through the roof. But importantly, on the left-hand side, we can see that the performance of this database went almost to 0, right? Because the only thing that we're guaranteeing for that database is 100 IOPS. And at this point, we know what happens. We've got a database administrator who calls and starts yelling at his storage team because what the hell's wrong with the storage, right? The typical story that we see over and over. In a traditional environment, we move the database at this point. We find a better storage array. We find a different tier of storage. We do something to manually remediate this storage that includes moving the data. From a SolidFire standpoint, we go into the UI and we change that 100 minimum IOPS to 15,000 minimum IOPS. And the bootstorm still keeps going, right? We're still going to drive more throughput to the box. We're still going to drive more I/O to the box, but the volume that database is running on is now guaranteed to have 15,000 of the IOPS that's available on this cluster. And both the bandwidth and the I/O for that database go back to where it needs to be. It goes back to making the database administrator happy, regardless of the fact that that bootstorm is still happening. And so it's a really powerful way to co-locate workloads that traditionally couldn't be, right? Oracle or SQL databases sitting on the same storage array as VDI workloads is not something that can be traditionally handled in a dual controller storage architecture, but that's exactly what we're trying to drive from a SolidFire standpoint. We want to be able to allocate storage and performance independent of capacity. We want it to be more manageable, so real-time changes to either the capacity or the performance. We want to be able to guarantee that and protect workloads from each other. We want to enable lots of consolidation, true and real consolidation. And we want to reduce the amount of time spent managing performance issues. Moving databases, scheduling downtime, all of those things become irrelevant when I have the ability to immediately take any of the capacity or performance of the storage array and throw it at the volume that needs it. Next, we put some automation in place. The only first-class management citizen that SolidFire has is the API. The API is baked in as part of the product. It's not an add-on. It's not a standalone. It's not run by a different product team. And that API gives us the ability to do really deep integration with both management and orchestration platforms, but also custom apps or custom frameworks that customers have put in place. to be able to provide user-facing storage controls. When this automation is embraced, what we're really doing is reducing the risk of the human error, reducing the manual pieces and time that have to go into provisioning out the storage. And by extension, that provides better availability. There aren't mistakes that get made. It also helps lower that operating cost pretty significantly. So the API is the fundamental point of management. Everything that we do, whether it's VMware or OpenStack or anything else, gets built on top of that. And when we look at that kind of complete system automation environment, whether it's customers building self-service portals or doing integration with the API, or it's us providing OpenStack and CloudStack and VMware integration, it's us providing Python or Java or .NET SDKs for customers to be able to use the development languages that they've traditionally used, or even things like SNMP and PowerShell, being able to take data center staples, scripting staples, and leverage those as a way to control the SolidFire storage array. All of this happens because of that API and because of how central it is to the operation of the storage array. Nothing that we do from a storage standpoint isn't published in the API. So that documentation is open and transparent, and customers can do with it whatever they need to. We want them to rapidly deploy those services. We want them to distribute that data and eliminate downtime. And we want the REST-based APIs to really drive down the amount of time, cost, and energy that it takes to automate that data center. The more transparent and programmatic we can be, better off customers will be trying to consume it inside their data centers. And then the final of those 5 pillars is the inline data reduction. Like most all-flash arrays, the deduplication, compression, and thin provisioning is always on, inline, every volume, all the time. What's interesting with SolidFire is that deduplication domain matches the size of the cluster. So it's not tied to a disk group. It's not tied to an aggregate. It's not tied to a pair of controllers. It's tied to however much performance and capacity is in the pool that you're provisioning. So over time, as nodes get added into the SolidFire environment, the deduplication ratio gets better. The number of workloads that we consolidate makes that better. The number of replication targets that we have extends that dedupe domain out even further. So in addition to having the technologies, being able to marry that up with the architecture provides a really powerful ROI tool for customers over time. Solution benefits, obviously cloud VDI databases. What we've seen lots of customers do is take a workload that compresses or dedupes really well, like VDI, and essentially get that for free because the storage array was primarily purchased to drive a very low compression or dedupe application like an Oracle database, right? So, customers will buy what they need for the Oracle and for the database environment, and then will leverage the fact that they can provision so much more greater percentage of the performance and capacity in the cluster because of the way that QoS works, that they can essentially get the VDI environment that they're putting in there for free. It's the goal there is to drive that cost below the price of disk, and I think that not just SolidFire, but most of the all-flash array companies have done a pretty good job of that. So use cases, pretty straightforward. Private cloud, web infrastructure, workload consolidation is a huge benefit that we've been able to provide to customers as they narrow down from 10, 12, 14 different storage arrays from multiple vendors into one platform to manage. And then from the data center side, obviously developing and monetizing new services and speeding up application cycles. These are the places that SolidFire plays really well. VMware is a huge part of our business. The vSphere integration, particularly with vVols, which is supported in our next version of the Element OS release, which we actually announced here last month, is going to be a huge benefit. Being able to take QoS and provide it down to an individual vVol level is going to be something that's pretty exciting. Our validated interop there, but also the number of customers that we have that are seeing success that are largely driven on VMware is pretty exciting. But we've got the same thing on OpenStack. We've been a foundational member of the OpenStack environment. We built the Cinder block storage project and shepherded that through to where it is today. And so being able to provide this type of integration is very much a function of the combination of the architecture and the API that we have sitting on the back end. And again, the partners that we work with in the OpenStack community, but the customers who are driving our success in that community are pretty special to us. The individual building blocks themselves, we talked about it earlier that we can mix and match node sizes. Here are the 4 different types of nodes. The only difference between the nodes is the amount of capacity and the amount of I/O that each of them have. You can see that the first 3 have 50,000 guaranteed IOPS per node. The brand new 19210 has 100,000 IOPS per node. These are mix and match. So you start with 4 of whichever one makes sense initially, and then as you see how quickly it's growing or you see how excited you are to consolidate down workloads into a single array, then you can mix and match and figure out what's the right price point, what's the right density, what's the right total number of nodes that need to be purchased, and mix and match these as you go. And the feature set that we put in there is all-inclusive. There's no licensing for individual features, so 5 different types of replication, synchronous and asynchronous, integrated cloud backup to any Swift or S3-based object storage, snapshots and clones, all of the global efficiencies, encryption at rest, the logging, the cloud-based monitoring with our ActiveIQ product, the secure multi-tenancy, VRFs, VLANs, volume access groups, simultaneous support for Fibre Channel and iSCSI on a single volume, and then all of the integrations with all of the platforms that we need, including Docker, which is, I'm actually in Seattle today at the DockerCon event and have spent the last couple of days getting customers excited about our ability to integrate as a portfolio across all of the NetApp products with Docker has been pretty special. This is what we do. This is the design and the architecture that we wanted to bring to market. This is the product that we've used to really start helping customers change how they look at Flash, because obviously, as we've gone through here, Flash is not the special part of this. The special part is the architecture and the software. Flash is just a way for us to make everything fast and predictable. But if we marry that architecture, we marry that purchasing model and that consumption model with the best possible experience that we can within those five pillars of the software development process, what we've got is a really compelling product that customers are finding and learning about and seeing that it can be a very powerful part of how their data center looks going forward and how their IT organizations relate out to the rest of the business units that they're supporting. The F3 technology partners, this has been a really fun event to be able to put together with them. Hopefully there will be more of these. We're really excited about the partnerships, both the ones that we had as SolidFire before the acquisition, but especially the NetApp partners. It's been really gratifying to see the position that NetApp holds with the partners and in that partner community, and being able to bring something new to the table or being able to talk to different customers or different types of workloads has been a lot of fun. So if you want to learn more about the F3 Technology Partners team or any of the solutions that they provide, both NetApp SolidFire as well as the rest of the technology portfolio that they're using to help solve customer problems, the contact information is down there at the bottom, and I promise you that everyone who attended today will get at least one, if not multiple, email follow-ups to be able to circle around and talk about use cases or talk about proof of concepts or talk about sitting down and digging deeper into the technology. And with that, I believe we are almost exactly on time. Were there any questions in the chat on the WebEx that we need to look at?
There is a question that came through. Can QoS really stand up to failures? Also, what happens to the amount of dedicated I/O? Will my application suffer?
Good question. So QoS is designed to be maintained within any failure mode. So the total amount of capacity and performance of a storage array will go down based on whatever failed. So if we have a 4-node cluster that has 40 drives and we lose one of those drives, we're going to lose 1/40th of the performance and capacity of the cluster. But what we don't do is compromise the ability to enforce the QoS values that have been in there at all. So what may happen is, if the capacity was if the cluster was at full capacity and we had a failure of either a disk or a node, what we may have to do is push volumes down from their maximums, right? We'll back volumes off of their maximums in order to be able to always enforce the minimums that are in place, and we will back those off at different rates based on the spread between the minimum and the maximum. So volumes that are very tuned in where it's a narrow spread between the minimum guaranteed and the maximum available, will be impacted last, whereas volumes that have a very low minimum and a very high maximum, and there's a huge differential between them, will get backed off quicker. So even during failures, whether that's node or disk, the ability of QoS to be able to satisfy those minimums and the algorithm that we use to be able to back volumes down if there were contention, right? On a cluster that has plenty of overhead or plenty of headroom, there's no real need to there's no real need to worry about it at all. But even on a cluster that's nearing capacity, being able to maintain the minimums on the QoS side is something that's absolutely paramount to the Element OS software stack, and is something that was built into that from the ground up.
Great, thanks, Jeremiah. Looks like there's a follow-up question. Do existing SolidFire customers run multiple production applications on a single array, or do they have separate arrays for Oracle and VMware, for example?
Good question. We generally see customers start with a single workload on a SolidFire storage array, and then once they're comfortable with how QoS works and once they're comfortable with how the consolidation story looks, we see them driving multiple production workloads in almost immediately. In fact, one of the demos that we did for VMworld last year included an OpenStack environment where we spun up 1,000 web servers, a VMware environment where we did a full boot storm of 200 VDI desktops, a five database Oracle Mart application, and a 6-shard MongoDB environment. And what we did was, with all of those running on a single 4-node SolidFire storage cluster, was we let customers go in and kind of hit the disaster button, right? We would do a full backup or a full table update on the Oracle side, and we would watch what the response time was of the VDI desktops. We would reboot all of the VDI desktops and see what that did to the CPU ready time or to the latency of the queries on the Oracle side. We would double the ingest rate of the MongoDB environment and watch what that did to the rest of the workloads that were on there. And all of that to prove that when we set the QoS gets respected regardless of what's happening. And that makes it easier to provision and allows us to be much more efficient around the total amount of the purchased performance and capacity that can be used, but it also very much protects those workloads from one another. So I think most of our customers will have a specific workload that they will want to try, and then once they get comfortable with the operational method, once they get comfortable with how QoS gets set, they move that second workload in, and at that point, the seal comes off. And as storage arrays come off of maintenance, as storage workloads change, and what would traditionally have been an inflection point that means moving to a different tier of storage or moving to a new or separate storage array, now that stuff gets consolidated in. And if we've got multiple environments, if we've got a VDI or a VMware environment and an OpenStack environment, since the platform is built to be multi-tenant, we can deliver those over separate storage networks. We can deliver those through traditional fiber channel security methods with zoning and masking. We can provide separate authentication for each of those. We can provide separate reporting for what sort of capacity are they using and what sort of efficiencies are they seeing. So we're not only designed to handle multiple workloads from a technical standpoint, but from a reporting and operational standpoint, the product is very much designed to do that as well.
Great. Thanks again, Jeremiah. And it doesn't look like we have any other questions, so I'll turn it back over to you for closing remarks.
Excellent. Well, thank you again for the time. I know the webinars can be, an imposition in the middle of the day. Hopefully this wasn't too difficult for everyone. If you have any questions, I will go ahead and put the slide back up with the F3 Technology Partners contact information. If you have any questions, please reach out. If you've got anything that you want to see more of, or if you've got anything that you want to dig deeper into, that's what we're here for. We'll certainly get those scheduled. But thanks again for all the time. Thank you to everybody on the back end who makes these things go off as seamlessly as they do, and hopefully you'll join us for the next one. Thank you, everybody.